Hi there everyone, welcome to Edupedia World 9th Grade Computer Applications video lecture series. I'm Upeka Vendibona, and from this episode we are going to talk about an important object-oriented design principle, encapsulation. First of all, let's recap what we know up to now. We know what are the classes and what are the objects, and we know classes are the blueprint for objects. Classes define what an object knows and what an object does. Things an object knows are its instance variables and it represents the state, and things an object does are its methods and that represent the behavior. So methods can use instance variables so that objects of the same type can behave differently. If we take the dog class, we can create many dog objects using that class, and each object can have different instance variables. For example, the name can be different, the size can be different, and breed can be different. And also, if we take the methods, they can behave differently according to the instance variable value. For example, depending on the size of the dog, he may bark in different ways. The big sized dog may bark in louder voices and smaller dogs may bark in smaller voices. A method can have parameters, which means you can pass one or more values into the method. If you want to make the dog bark 3 times, you can send that number 3 as a parameter. And then the number and the type of values you are passing must match the order and type of the parameters declared by the method. If a declared method have 2 parameters, one is a int parameter and the other is a boolean parameter, the method calling should pass 2 arguments in the same order, int or a applicable lower size data type value and a boolean value. So that means if you are passing a lower size data type value, you can implicitly promote that value into a larger type. So if you are passing a short variable value, you can implicitly promote it into a int type value. The value you pass as an argument to a method can be a literal value, for example number 2 or letter C, or variable of the declared parameter type, for example x, where x is an int variable. A method must declare a return type. A void return type means the method doesn't return anything. Think of a method that only contains println statements. So surely that kind of a method can have void return type because it is not returning any value or anything. But think of a method that calculates the average marks. So at the end of the method, it will obtain a value, the average. So if we want that average as an integer variable, so surely that method have a return type, int. If a method declares a non-void return type, that means int, boolean, etc., it will return a value compatible with the declared return type. So if we are returning an int value, the average mark from the method using the return keyword, at the method declaration it should mention int as the return type. And also, if the caller method assigns that value to a variable, that variable should have an applicable data type. From the previous episodes, we demonstrated everything that we have summed up in here. If you have missed any point, please check our playlist. And now let's start today's session, encapsulation. Now that we have seen how parameters and return type works, it's time to put them in good use. Getters and setters. It will let you, get and set things. Usually the instance variable values. A getter's sole purpose in life is to send back and return value. The value of whatever it is that particular getter is supposed to be getting. And the setter. Setter lives and breathes for a chance to get an argument value and use it to set the value of an instance variable. Now take a look at this movie class. It has 3 instance variables: title, genre, and rating. And each of the instance variables have 2 methods: to set the value and to get the value. So that means there are 6 additional methods for that purpose, to get the value and set the value of the instance variables. In addition to that, there is another general method, play. And also look at how the getter and setter methods are written. They should clearly depict which instance variables they are referring to. Now let's try to implement this thing. And here we go for the movie class. Inside the movie class, we have 3 instance variables: title, which is a string variable, and we have another string variable as genre, and the rating is a int variable. Okay, now it's time for the getters and setters. First, the setter of the title. Inside the parentheses of the method, we have to capture the value that is sending from the method caller. So it is a string value. So the parameter should be a string value. And we say it is the title name. You can use any name as you prefer. Inside the method, we are going to assign this title name value to the instance variable title. So that is how the setters are written. And now for the getters. And here we have to declare the return type. So we are returning a string value because the title is a string value. So the return type is string and the method name is getTitle. And inside the method we are returning the instance variable title. So that's how the getters are written. Now let's go for the setter of the genre. Inside the parentheses, we are declaring the parameter. And this time I am going to use the same name as in the instance variable. In the title setter, we use a different variable name, but now we are using the same name as in the instance variable. If we are using the same name in the method, we have to use the this keyword to refer the instance variable. This genre equal genre. So in this part we are referring the local variable, which is the variable we declared inside the method, and this .genre means the variable instance variable. We will later get into know what is actually this keyword, but until now just remember, if we are using the same name as in the instance variable inside a method, to refer the instance variable, you have to use this keyword. Now let me quickly write down the getters and setters of the remaining. Okay, we have write down the movie class. Let me save this file and quickly go to create the main class. The main method. So inside the main method, we have to create a movie object. Now let's assign some values for the instance variables. Title, genre, and the rating. Okay, we have created one object and assigned few values for the instance variables. But to assign the values for the instance variables, we use the dot operator. But for that purpose, we have created few methods: set title, set genre, and set rating. So let's create another object and use that way to assign the values for the instance variables. So inside the parentheses, we will send the arguments. In here, we have used two ways of assigning values to the instance variables. One way is to use the dot operator, and it is a way of directly assigning the values. The other way is passing the values as arguments to the methods, and it is a way of indirectly assigning the values to the instance variables. And now let's save this file. Compile to check whether there are any errors. Okay, we got two errors in the line 19 and the line 23. It is important to understand the errors. So the first error is semicolon expected. So in the line 19, the semicolon is expected at the end of the return statement. Let's see whether we have missed the semicolon. Yes, in the line 19 we have missed the semicolon. Let's put the semicolon. And the next error is in the 23, and it is also missing semicolon. Okay, now let's save this file and compile again. So in the command prompt, by pressing the up arrow key and the down arrow keys, you can go throughout the commands that you have previously entered. So rather than typing everything, you can use the arrow keys to use the same command again. So this time it's compiled. Okay. And now let's compile the main class. There are no errors in the main movie class. So now we are done. So here we demonstrated two ways of assigning the values to the instance variables. Now I'm going to show you the usage of getter methods. For that, I'm using a println statement. So here I'm going to concatenate the title get method caller. And then again I'm going to insert some text. And here I'm going to call the movie1 objects get rating method caller. So this is our println statement. Now I'm going to save this file and compile this file. So no errors. Now I'm going to run this file. And here you can see how the println statement works for the movie1 object. For the movie1 object, we use the dot operator to set the values. And let's do the same for the movie2 object. So here I'm going to change the object as movie2. Let's save the file and compile again. And here I'm going to use the arrow keys to use the previous command again. No errors, so I can run the file. So here you can see for the movie2 object, movie, the avatar got rating 5. Is it good idea to leave your instance variables exposed? Exposed in the sense reachable with the dot operator. Think about this idea of directly changing the cat's object size instance variable. In the hands of the wrong person, a reference variable is quite a dangerous weapon. Now imagine I am receiving the cat class file. Typically we do not get the source code file, we only get the compiled version, the class file. So I am receiving the cat class file. And it's my duty to write the main class, which includes the main method. So using the main method, if I can directly access the instance variables in the class file, it's not a good idea. This is what would happen if I can directly access the instance variables. The cat.height equals 0, and there is no way having 0 height cats. This would be a bad thing. We need to build setter methods for all the instance variables and find a way to force the code to call the setter rather than accessing the data directly. So this is how we can control the setHeight method to avoid 0 values. So we are passing the parameter int parameter ht, and we are checking using the if condition whether the height parameter value is above the 9. So if above the 9, we can assign that value to the instance variable height. So with this condition, we can avoid 0 values. When someone sends the argument as 0, then that 0 would be not assigned to the instance variable. Even though we control the method to avoid 0 assignments, someone can access the instance variable directly and assign the value 0 using the dot operator. So how to avoid that? How to force someone to call the setter method? So to do that, we have to hide the instance variables. To hide the instance variable, we need something called access modifiers. And you are already familiar with the public access modifier. And here is what you have to do. For instance variables, mark it as private and provide public getters and setters for access control. When you have more design and coding savvy in Java, You will probably do things in a differently, but for now, this approach will keep you safe. In overall, what we did in here is called encapsulation. So what does this kind of an encapsulation protect you from? Encapsulation puts a force field around objects' instance variables, so nobody can assign an inappropriate value. If we take an example, most instance variable values are coded with certain assumptions about the boundaries of the values. Like, think of all the things that would break if negative numbers were allowed. Number of bathrooms in the office, velocity of an airplane, birthdays, mobile phone numbers. So these kind of variables cannot have negative values. So what would happen if someone assign a negative value? We can avoid that kind of happening by encapsulating the class. So how does encapsulation let you set boundaries? We can easily set boundaries by forcing other code to go through the setter method. In that way, the setter method can validate the parameter and decide what should do. Maybe the method will reject it and doing nothing, or maybe it will throw an exception. And don't worry, we will discuss about exceptions in another episode. And maybe the method will round the parameter, send into the nearest acceptable value. The point is, you can do whatever you want in the setter method. But sometimes you will see setter methods that simply set the value without checking anything. Doesn't that setter method create unnecessary overhead? A performance hit. The main focus of getters and setters is that you can change your mind later without breaking anybody else's code. Imagine if half the people in your company use your class with public instance variables, and one day you suddenly realized, oops, there's something I didn't plan for that value. I'm going to switch to a setter method. And then you break everyone's code. The cool thing about encapsulation is that you can change and nobody get hurt. And now go back to your code and try to encapsulate the movie class. And remember, instance variables have private access modifier and the methods have public access modifier. So here we are back with the movie class and we say we have private instance variables. Private string title, private string genre, and private int rating. And we say all the methods are public methods. Okay, now we are done with the movie class. And now let's try to save this and compile. So no errors in the movie class, therefore we can run the program. If you can remember, in the main movie, we have used two approaches to assign the values for the instance variables. One way is using the dot operator and the other way is calling the setter methods. So let's see what would happen when we run this program. And here we got an error. Exception in thread main java.lang.illegal access error, and that is the name of this error. Try to access field movie.title from class main movie. The title field in the movie class is a private field. Therefore, we cannot access it from another class. Private fields can be accessed within the same class. If we are trying to access the private fields from different classes, we will get this kind of an illegal access error. So now to correct this, I'm going to remove the movie1 stuff from the main movie class. And let's save this and compile. Okay, no errors, and let's try to run this program. Okay, everything is perfect. And that's all what we got in here. From the next episode, we are trying to look at more about variables, and you already know about variables, but there is more to learn. So stay tuned on, and thank you for watching. This video brought to you by edupediaworld.com. Watch more from our website.